Okay, so we need to do this question. It's the question labeled number 3. A manager is in a rapidly growing industry wishes to study the effects of motivation on salespeople. They tell you a lot of stories. It's a long story. And then they give you a table. If you read carefully, they tell you they have 6 employees. And they're going to see uh, the sales volume. If they ask each one of them to work hourly rate and to work commission and to do combination of both of them. Like for example, if you look at the table, employee number 1, sales were 256 if he worked hourly rate or she. The employee number 1, if worked commission 224. And if you work combo, it would be 269. And that's the same for all 12. Again, we obviously have 3 or more groups, so again it's ANOVA. But like I did in the previous part, is it single ANOVA or double ANOVA? The last one, it was 6 different people, 6 under business grad, under professional, so we have 6 groups, different groups. Here, you have 12 employees, and it's the same 12 under first group, the same 12 under the second group, the same 12 under the third group. This is ANOVA double or two-way or the blocking system. Okay, and the question is there evidence that commission and combo and hourly differ on average? So you're comparing the 3 groups. So you say mu1, mu, or if you want to be specific, mu of hourly rate equals mu commission equals mu combo, or at least one is different. Test is the F effect, MS effect over MS total. That's always the formula for ANOVA. Decision rule. If you F test more than the table, you're going to reject H0. Don't worry about it now, we'll come back to it later. But let me tell you something. A lot of people jump into this question and do it this way, but I want you to think about it a little bit. I'm going to do this also later. You're comparing the 3 groups. What if they tell you, are the employees different? What if they want you to compare the 12 employees? So you would say mu employee 1 equals 2 equals 3 all the way to 12. At least one is different. And in English, the average sales for hourly rate equals the average, maybe we should have it here. Average sales for hourly rate, commission, and combo are equal. And here you said the average rates are different. So now remember, if you ask to compare these tables, if you're asked to do it this way, it would be double ANOVA treatment. And that's what you have. You're comparing the 3 treatments. If you're asked to compare whatever you have going this way, rows, that would be block, or the rows. And these would be the columns. Okay. Again, you're given the ANOVA table. I'll go through the ANOVA table. They tell you source. They say the word rows, columns, error, and total. Rows, they mean the block. Columns, they mean the treatment. They give you the numbers 719675. This one is 689867, say. This one is 6433 something, and this one is 20,502.75. And if one of them is missing, you know, these three must add to the total. So if this one is missing, you go this minus the other two. Degree of freedom. Well, they don't give you any of them. Well, they give you all of them, sorry. But what if they don't give you any of them? Remember how I did it for single ANOVA? For double ANOVA, degree freedom for blocks and treatment are a bit different. Here, how many blocks do we have? Minus 1. So there are 12 employees, minus 1, 11. Treatment. How many treatments do we have? How many groups do we have? 3 minus 1, 2. For the error, you multiply these two. 11 times 2, 22. And here, you just add them. 13 and 22, 35. So this is how you do it. So look at the one we did for single ANOVA, the previous video. You'll see that the degree freedom are a bit different in the single ANOVA than the double ANOVA. MS is the same. You divide each one by the degree of freedom. So the first one you divide by 11. It will give you 654.25. You divide this by 2. It will give you 344.933. You divide this by 22. Gives you 29242. And we don't need this anymore. And then your F number. Here, it's a little bit tricky. We need the F number that corresponds to the block. And to do the F that corresponds to the block, we take MS and you divide by the E. Remember, always divide by the E. So to do the F for the BL for the block, I'll divide by the E. 654 divided by 29, this will give me 2.2464. And to do the F number for the columns or for the treatment or for the group, we take MS, we also divide by the E. It's always take the MS over the E. So 3,449 over 291, this will give you 11.8435. Okay. I'm gonna, so have a good look at this. I'm gonna erase some of this to allow some space. So we have, and that's the goal, is to find the two FSs. But eventually, when you make a conclusion, you only need the one that goes with the question. We're doing it treatment. We're comparing the three columns, so we need the second one. You still have to calculate both, but we need the second one. We don't have this number. We get it from the F table. The degree freedom going this down is always the degree freedom for E, and that's 22. The degree freedom going this way depends. Are you comparing the treatment or are you comparing the blocks? We know that we're comparing treatment, so we take the degree freedom for treatment, which is the column, which is 2. At the given alpha, and I think alpha was in the question, 1%. So if you use 1% alpha, you go to the F table that you have. You see, if you're using, Saagh lost the table where the 222, they would have like 4 numbers. This one would be for the 10%, this would be for the 5, this would be for the 2.5, this would be for the 1%. Obviously you need this one. And this one is, if you look it up, it would be like 5.719. That's the number you're going to compare to. Ready to make a conclusion. So your number, your F test, I'm going to take the treatment. It's 118435. That's way more than 5. So we're going to reject H0. We're concluding HA. Type 1 could be committed. Risk equals alpha 1%. In English, we have enough evidence to show at least one of the 3 groups different. Then yes, one of them is different. She wants you, if you're asked to do with p-value, again, you find the p-value using one of the websites. They will give you a p-value very close to 0. So if you use one of the websites to find the p-value for this would be very close to 0. So the decision rule under p-value, I wrote it for the first question, is standard. P-value less than alpha, reject. H0. But if your p-value is almost 0 and your alpha is 1%, then we're rejecting H0, concluding HA. Same conclusion. Okay, now what if you're asked, let me erase this, to compare the employees? What if they want you to do it using the block technique? If here are employees different, well, you would say 1 equals 1 all the way to 12, at least one is different. So in English, the average sales for employees, not different, and here at least one is different. Test, it's the F test, and it's always M effect over MS F. Decision rule. If my test more than the table, reject. We can get this number from the table. The down E, but this way, going this way, would be the degree freedom for the block, because you're comparing the blocks now. And that would be 11. So down, your 22, I believe it was, and this way 11. And if you go to a table, you'll see there are 4 numbers you need the one that corresponds to 1%, and if you do this, it would be 3.1837. So the number you're comparing to 31837. Now, if you do the calculation, you do the same exact calculation, but after you do this, you pick the one you need. Now we need FBL. FBL is 2.2464. That's not more 31837. Not more than 3107, so we're not rejecting H0. Don't reject H0. Don't conclude HA. That's type 2 could be committed and risk equals beta. Not concluding, so we don't have evidence that at least one is different. We do not have enough evidence that average sales for employees different. So this is it for double and over. If I had more time, I would have probably given you more questions, went into details, but I think this is good. This explains the major concept of chi. We did the two versions of chi, and single ANOVA, double ANOVA. We did both of them, and the regression will be the last part. I'll send it to you. I might do it in multiple parts. I'll see, but that would be the last one. Okay, bye.